One place where SKF solutions are put to the test is on an offshore oil rig. Here, mud, dirt, and contaminants can quickly reduce the service life of any piece of equipment by attacking the bearings. And nowhere is that more evident than on the bearing stack at the end of a drill string. If you look at the driven end of the string, you'll find a mud motor, or a Moiner motor, as it is sometimes called. To drive this mud motor, mud under pressure is pumped down the drill string to drive a rotor and the drill bit shaft. The mud is also used as a cutting fluid to cool the bit and remove debris from the well. To accommodate the high axial loads and keep the drill bit turning smoothly, a stack of 4-point angular contact ball bearings are used. These bearings must be able to accommodate very heavy axial loads while enduring severe shock loads. But to make matters worse, these bearings are lubricated with mud, a scenario that defines severe operating conditions. Typically, a bearing stack lasts about 1 to 200 hours. That's not a long time in terms of bearing service life, but under these severe conditions, standard bearings just can't go beyond that point, which is why SKF developed a new bearing set for mud motors. To better understand these new bearings and what they do, let's take a look at how the typical mud motor works. As a drill bit turns, the first few rows of the bearing stack are carrying the primary load, with the lead bearing carrying most of that load. Then, as the first row starts to wear, the primary load is transferred to the next row in the bearing stack, and the next, until all the bearings are worn equally. At this point, the load is transferred back to the first row so that the process can repeat itself. In the past, no one really understood what the bearings had to endure at the end of the drill string. Today, however, SKF engineers, with their advanced computer modeling programs, are able to accurately define the behavior of a bearing stack in the mud motor. These advanced modeling programs also act as virtual test rigs to aid researchers as they test new theories and materials faster than ever before. For example, with a virtual test rig, SKF engineers were able to better understand the problem of cracked rings and sheared balls, a common problem with bearings in mud motors. The research also gave SKF engineers the information they needed to develop special wear and impact-resistant steel. The result? A bearing stack that will last significantly longer than the bearings in your mud motor today. They will decrease maintenance and increase the number of downhole runs to improve performance and increase reliability. At SKF, we work under real conditions to provide you with real solutions. Not just bearing solutions, but solutions that will enable all machines of the future to increase uptime, decrease downtime, and improve profitability. SKF, the knowledge engineering company.